lecture in our pre-recording in a very more concise fashion, right? So in this case, okay, we always start whenever we talk about memory, we always start with this classical model. Sometimes it's also called the standard model. Okay, the Atkinson Shiffrin model. So it has three parts. Okay, from our sensory registrar. Okay, sensory registers, also called the sensory buffer, right? And then it transfers all this information to our this short-term memory, okay, STM, and then that's where we have this short-term rehearsal, okay. And then later on, the third pathway will be to transfer all this information from STM to LTM, okay, long-term memory. Um, so the difference between STM and long-term memory, if you really want to talk about the specific time interval, the specific duration, okay, that is up for different kinds of experimental design to decide, all right? But as far as I'm concerned, okay, usually when we talk about STM, okay, we're talking on a scale of minutes, okay, on a scale of minutes. LTM is usually on a scale of hours, all right, on a scale of days, yeah. And sensory register, we're dealing with milliseconds, right? Not more than 2 seconds to be really precise, actually. All right, it's really milliseconds. Later on, I will show everybody what I mean, right? And of course, I mean, very, very commonsensically, right? If all this information do not get rehearsed, right? Do not get rehearsed in your STM, they are rapidly lost, right? Memory is being lost, yeah. So that's how, right? I mean, at all these three different stages, memory gets lost. But memory gets lost the fastest, I would say, sensory register part. Yeah. All right, so this is a slide from my deck of slides. All right, just want to show everybody. So this is what's happening. So instead of saying memory loss, it says forgetting. Yeah. So sensory memory. Yeah. So I said that just now, right? So it lasts up to 2 seconds, right? Large capacity that's kind of found in those classical experiments, like kind of inferred, lah, right, from George Miller's experiments in the 60s. Yeah. So, during that time, there's this so-called cognitive, revolution, right? Cognitive psychology movement, right, in the USA, right? So during that time, there was so many experiments, concerned with sensory memory, short-term memory. So his was one of those. So what he found out was that, sensory memory, the buffer is like 300 milliseconds. Wow, it's like 300 milliseconds, and then people can actually register 3 rows of letters. I mean, that's what he found out, right? I personally I find that a little bit unbelievable, right? And I'm not too sure about the replication of that study, but do look it up, right? So then short-term memory, yeah. So in this case, the Atkinson Shiffrin model initially proposes like it's on the scale of seconds, yeah, on a scale of seconds, right? But it can also be like a few minutes. That's definitely for sure. Right, so small like 5 to 9 items. So we heard about this thing, right? Like working memory, like 7 plus minus 2 uh, chunks, right? Chunks of information, right? So we can retain, that amount of information, 7 plus minus 2. Okay, yeah. In my experiments, I also replicated that, which is, I don't know why is it like that, but that's really like a highly replicated phenomenon. Yeah, 7 plus minus 2, yeah, chunk of information. All right, and then storage, of course, in long-term memory, and then we have retrieval. So it's kind of believed lah, that this long-term memory will last indefinitely. Okay. All right. So I mean that's classically believed, lah, right? Classically believed, right? But of course, I mean recent experiments will show you otherwise. I mean, of course it deteriorates with aging. All right. I mean, you have brain damage, some kind of psychological disorders. Right. Definitely, it will not last indefinitely. Right. So that's something to take note of, right? Unlimited capacity. That's what was believed, right? But okay, I mean these days we just not too sure. I think there's just huge individual variation, right? It depends on your knowledge, your education level as well, right? Okay, now I just want to talk about this updated information processing model, right? We have this thing in our deck of slides already, right? So um, So the only difference here, right, is the one in the middle, right? Short-term memory becomes working memory, right? Why do we like to use the word working these days, right? Because working is suggests some kind of active processing is occurring. So there's some kind of manipulation of all this information coming in, right? It's not just a passive, reservoir of information, right? Like, I mean, STM is a passive, term, right? I mean, short term, okay, what is it for? I mean, how short is short, right? Nobody knows for sure, right? But then Alan Bentley comes and then, yeah, he wrote like a series of papers, I think, like 30 years ago. And then basically he talk about all these three different components or modules, okay, like the mod that we're taking, all right? So starting with central executive at the top, and then this VS sketchpad, visual spatial sketchpad, right? At the bottom, right? There's two, right? So and then there's this verbal phonological store, right? Yeah, or the phonological loop, yeah. So it has this, yeah, articulatory or this phonological loop, right? So he actually rehearses all this, phonetics, right? All these sounds that we hear, right? From all these different languages. Yeah. So this is actually in a beauty way, lah. So this is like a kind of tripartite design, okay, like triangular design. So very very simply, it just links up, the non-verbal with the verbal, linguistic information, right? So it's a kind of a genius, and then you have the central executive. He's like the manager, managing the interrelationships, right, between these two, subcomponents, right? All right, and then there's intercommunication between these three modules, all right? And then this has been shown, right, in our brain. So we do have, different kinds of functional connectivity or connections, right? Functional connections between different regions of our brain. Yeah. So usually when we talk about central executive, we're talking about this dorsolateral prefrontal cortex, right? So it's the Broadman area 46, right? That is usually, yeah. So that is the area that has been replicated in thousands of neuroimaging experiments. Okay. Visual spatial sketchpad, just for everybody's information, it's more like our occipital lobe or parietal lobe. It's a pretty big area, lah, right? So, verbal phonological stores is for some of you. That's like maybe like our Herschel's gyrus. That's our middle temporal gyrus, right? Somewhere in the middle, right? So, I mean the covering, lah, right? I mean the piece of brain tissue covering our thalamus. Yeah. So that's the verbal phonological store, right? So we do have overlapping but discrete, brain regions that's kind of involving all these working memory functions. Yeah. And then the last thing I want to highlight, all right, is that within this long-term memory in this updated model, right, is that there is this consolidation and reconsolidation mechanism, right? There is this process occurring. So in our long-term memory, is like, things can go fuzzy, things can become very, very vague over time. That's why it's a kind of double arrow, right? So it's, not just like information from central executive flows forward, right? The thing, the long-term memory also has to go back, feed backward, right? So feed forward, feed backward, yeah. So that's how. And then all this information, it has to be consolidated and reconsolidated, right? So it undergoes many many iterations, repetitions of information enhancement, right? In other words, so this is something to take note of, right? Okay, now we look at this tree diagram from our textbook. The interesting part about this diagram, all right, is not about all this, different memory terms. Okay, that's understood already. I think what is it so unusual? What is it so unique about this diagram? Is that it actually separates this knowledge that we have, right, into two subdivisions. The one that is stored and the one that is expressed. So he wants to separate something that is passive and versus something that is active, right? The way knowledge is expressed. So this is extremely unusual. I think yeah, this textbook is one of the very few, or maybe like the very first one I've seen. Yeah, so maybe this is a current trend. I'm not too sure. Okay? Maybe this is the current trend in the memory research domain. Um, so just remember, so the way that our authors want us to see, like this implicit memory is not something that is totally equivalent to procedural memory. So implicit memory, you want to tie this thing to behavior. Yeah. And then this explicit memory as well does not really want us to see declarative memory as part of explicit memory. Usually that is the case. Okay. Usually that's the case. Okay. And even if you say that declarative memory is a form of explicit memory, okay, that is correct. Okay. Not the reverse. Okay. You cannot say that explicit memory is part of declarative memory. Okay. Because explicit memory is a bigger umbrella. Okay, it's a bigger umbrella, right? So, but in this case, you just want to see explicit memory as the activity that we do, lah, right? So this is recall and recognition, right? So this is what you guys have been doing, right, over the weekend, right? When you do the first test, right? You're recalling, and then you're recognizing all the key terms, right? When you're selecting your responses, right? And declarative memory on the left side, right? So in a passive sense, all right, in a passive sense, right? So it relates to our episodic memory for specific events, all right? When was the last time I studied psychology, for instance, right? And then your generic, your semantic knowledge, right? So that is really related to a linguistic understanding, right? The processing of words. Yeah. So this is what's happening right now. And then procedural memory, instead of relating it to behavior, is like, tying this thing to our stored knowledge of our skills, of our habits. I personally, I don't really see it that way, lah, like, just seeing as knowledge store. I see it as encompassing both storage and action. Yeah, that's for me, right? That's a conventional view, right? But anyway, I mean, just in the context of our textbook, know about this, unique distinction, all right? Just know about it. Okay, so before I carry on, I just want to show another diagram from biopsychology or cognitive psychology textbook, right? So this is like the conventional tree diagram, right? So when you look at this non-declarative implicit, okay, implicit LTM, right? So we're talking about procedural memory, yeah. And then of course classical conditioning, priming, all right, our operant conditioning. These are all part of our implicit memory, yeah. Okay. So maybe it's in this sense, right? You want to tie everything to learning and behavior. Then that's why they put this implicit, right? As very action oriented. Yeah. And then declarative. Okay, we have our semantic memory. Okay, this is understandable, right? And then episodic memory, and then very interestingly, this diagram actually tie both, right, semantic memory, episode memory into this autobiographical memory. Yeah, okay. Personally, I just see autobiographical memory as episodic memory. Yeah, I don't really see it as something that's too distinct, right? Okay. But in this diagram, you just want to make everything a little bit more interesting, right? Yeah. So be wary, okay? Be aware of all this, all these adjectives, right? They can turn out to be confusing, all right? And of course, you need to be aware, okay, of what you are writing, okay, when you are referring to all these different memories in your review paper, all right? So all this physical activity, as I said, in my opening slide, right? Most of the time they are helping us with regard to this implicit memory, okay, implicit memory, procedural memory, okay. Yeah, so as for improving, declarative episodic memory, I'm not too sure, okay, I'm not too sure, right, based on my understanding of this cognitive aging literature, right? So now